Okay, in this video, we're going to do notes on solving exponential equations. And there are some tips on the front of the notes you want to be mindful of as we're working through them. So you want to be careful with parentheses when evaluating logs in the calculator. We're going to round all of our answers to 4 decimal places as we're working through these problems. And you're going to check using the calculator by substituting the answer you get for x into the left side, and then get an answer, and then into the right side and get an answer. Compare both sides of the equal sign to see if they are close enough to be considered approximately equal. Since we're rounding answers to 4 decimal places, they're never going to be exactly equal, but they should be close when we check. So let's start with example 1a. And in example 1, we're solving exponential equations that have a base of 10. So we're going to start with step 1 here. Get the base with the variable exponent alone on one side of the equal sign. So the base with the variable exponent is 10 raised to the x plus 7 power. So we're going to move this constant to the other side by adding 4 to both sides. And that gives us 10 raised to the x plus 7 power is equal to 14. Okay, now we're ready for step 2 to take the common log of each side. We're going to use a common log because the common log is base 10. So we're going to take the common log of x, or 10 raised to the x plus 7 power, and we're going to take the common log we'll slide this 14 over some, make some room. We're going to take the common log of this side, which is 14. And then using the inverse property that we learned in the last lesson, the log base 10 of 10 to a power is equal to that power. So that brings the exponent down, x plus 7, and that's equal to the common log of 14 on the other side. So now to get x by itself in step 3, we're just going to subtract the constant from both sides, and that means x is equal to the log of 14 minus 7. Now here you want to be careful. Don't be tempted to combine that 14 minus 7. This is a function acting on the argument 14, the log of 14. So that is one term. It's not a like term with a minus 7, so they cannot be combined. Okay, instead we're going to use the calculator to get a decimal approximation for that common log of 14, and then minus 7, and we're going to round that answer to 4 decimal places. So negative 5.8538, and then because the next digit is a 7, that rounds the 8 up to a 9. So our answer will be approximately negative 5.8539. Now when we're ready to check that answer in the calculator, we're using a rounded value here. When we store that rounded value for x, so negative 5.8539 store as x, now we no longer are working with exact values. So I can't use the equal sign when I check because it's never going to be exactly equal since my answer has been rounded. So instead we're going to substitute the x into the equation on the left side, 10 raised to the x plus 7 power minus 4. And we see that that's equal to approximately 9.9991, which is very close to 10, right? It's close enough to be considered acceptable because we used a rounded decimal as our answer. So we can go ahead and mark that that checks. Okay, if you want to use the equal sign, then you're going to have to store the exact value in for the variable x. So log of 14 minus 7, and you store that exact value instead of the rounded one into the calculator. And then when you type in your expression, 10 raised to the x plus 7 power minus 4, and press enter, you'll see it does equal exactly 10. So in that case where you're storing the exact value as opposed to the rounded value, then you would be able to check it with the equal sign from the test menu, and you would get back a 1 for yes, it checks. Okay, but if you're checking that rounded value, you cannot use the equal sign because it's going to always be approximate and return a 0. Okay, so let's try example B. We've got a 10 raised to the 2x minus 5 power equal to 6. That base raised to a variable exponent is already isolated, so we don't need to worry about step 1. Step 2 is to take the common log of each side. So we're going to take the common log of 10 to the 2x minus 5 power and the common log of 6. Then using the inverse property, we bring down the exponent. 2x minus 5 then is equal to the common log of 6. And now we want to get the x by itself, so we'll add 5 to both sides. And then 2x is equal to the common log of 6 plus 5. And again, remember, you cannot combine that 6 and 5. They're not like terms. This is the log of 6 and then plus 5. So our last step to isolate the variable is to divide both sides by 2, and then x is equal to the common log of 6 plus 5 all divided by 2. So we're going to put that into the calculator to get a decimal approximation and round to 4 decimal places. So common log of 6 plus 5, and then we're going to divide that result by 2, and we have 2.8891 when we round up because the next digit is a 7. So approximately 2.8891. And then we can substitute that into the calculator for x to check. And if we use the rounded value, we would check the left side and see that it matches as close as possible to the right. So 10 to the 2x minus 5 is 6.0007, which is very close to 6. Or if you want to check the exact value, remember, instead of storing the rounded decimal, you need to store the exact answer. So that we would need parentheses around our numerator. So the log of 6 plus 5, that quantity divided by 2 is stored as x, and then 10 raised to the 2x minus 5 power equals 6, and it checks, we get back a 1. Okay, so go ahead and try this example on some scratch paper or individual whiteboard. 3 times 10 raised to the 4x power is equal to 12. And there's a note up here to help you recall some basic properties of exponents to help you if you get stuck. So give this a try, and when you're ready to go over it, resume the video. Okay, so we're back. We started in step 1 by dividing both sides by 3 to isolate the base of 10 to the variable exponent 4x. So 10 to the 4x equals 4. Then step 2 is to take the common log of both sides, and we have the inverse property then, which brings the exponent down of 4x, and that's equal to the common log of 4. Then to isolate the variable in step 3, we divide both sides by 4. X is by itself now and equal to the common log of 4 divided by 4. And remember, you cannot cancel those 4s. They're not like terms. So you evaluate in the calculator the common log of 4 and then divide that result by 4. Rounding to 4 decimal places is 0.1505. And then you can go ahead and check your answer. And with the rounded value, 3 times 10 to the 4x is 11.9983, which is close enough to 12 to consider that it checks. If you'd want to check the exact value, then you're going to store the common log of 4 divided by 4 as your x, and then type in your original equation, 3 times 10 raised to the quantity 4x equals 12, and we get a 1, so we know that that checks.